Hi, our electromagnetic theory course. In today's class, we will discuss about one of the important parameter in our electric field parameters. That parameter is nothing but electric flux density. First of all, we will see what is meant by electric flux. Electric flux means what? Electric field lines. Electric field lines are nothing but the flux. What is the main source for the electric field? Charge. Okay, due to charge we have the electric field. Electric field means what? Electric field lines of force. Of course, electric field lines are nothing but what? Electric flux. We know that the nature of the electric field lines, are open in nature. Means what? They started at a positive charge and terminated at infinity. Terminated at sorry, actually these electric field lines started at positive charge and terminated at a negative charge. Okay, so means let us consider a positive charge like this, that is q positive lines started at a positive charge and terminates at a negative charge. Means this flux or field lines emanates from positive charge. This is the location of the positive charge, and this is the location of the negative charge. In this case, field lines are started at positive charge and terminated at a negative charge like this one, and this one, this one, this one. Of course, we can draw another line like this also. So, consider an area S1, one. Here also some area S2. In this case, this flux crossing this surface area S1. Here, these flux lines in this surface area S2. Okay, if I want to measure the flux per unit surface area, in that case we have the flux density. Means what? Flux density is nothing but what? Flux per unit surface area. Of course, electric flux density is defined as what? Unit surface area. Unit surface quantity. Here, this one flux crossing this surface area, let us consider psi 1, and similarly for S2, let us consider. So, in this case, flux density d2. d2 is nothing but what? Unit surface area. Means what? In the numerator we have the flux, denominator we have the, yeah, then we can write this one as what? Psi 2 by S. Psi 2 by S2. Whereas in this case, here we have what? Psi 1 for what? Crossing this surface area S1. So in this case, we get what? S1. Yes, that means let us consider this as the first case. For the first case, we have what? D1 as what? Psi 1 by S1. Psi 1 by, as in this case, we have what? D2 equal to psi 2 by S2. Means what? If this area changes, this area it changes. In that case, flux crossing that area is also changes. Means what? We can write actually D is what? Flux per unit surface area. Of course, electric flux is represented by psi by S unit surface area. What we told, this area changes. If this surface area changes, so let us consider S3. Okay. In this case, crossing this surface area is different. Surface area changes, flux changes. So in general, we can write what? If this D, if this changes, ds. Okay. Change in surface area leads to what? S1, S2, S3 means what? S1 we have psi 1, for S2 psi 2, for S3 psi 3. Means what? If this surface area changes the change what flux crossing the surface area equal to d psi by ds. From this equation, we can given by what d or we know that ds is also vector. But what about this psi? Psi is due to what a scalar quantity charge. Is a scalar quantity means what? It is a source. It is a charge is a source and effect is what flux. Means what? Cause is cause is nothing but what charge and effect is nothing but what flux. Means this one is a scalar quantity. Is a scalar quantity. Our flux is also a scalar quantity. You know that any scalar quantity can be written in terms of the vectors, in terms of any two vectors, as what dot product of any two vectors gives what? It is a dot d bar dot d. Yes. Now apply integration on both sides. Integration on both sides. Apply integration on both sides. Integration differentiation cancel out here. Will remaining thing is what on left hand side side d bar dot ds bar. Again, I am repeating. It is a scalar quantity, so that's why scalar quantity can be written as what dot product of two vectors. One of the vector is d bar, and another vector surface area is also a vector quantity. So that's why to seeing this surface area, yes, take area as yes. In that case, psi equal to what? Integral d dot d yes. It is the relationship between flux, electric flux and electric flux density. This relationship is very useful to derive the one of the Maxwell's equation. We defined electric flux density as what? Electric flux per unit surface area. Electric flux per unit surface area. Area is the flux density. Electric flux per unit surface area is what? Electric flux density. We have another definition. We have another definition for this electric flux density. The electric flux density is also defined like this. That is d bar. Electric flux density is defined by d bar. Or can be defined like this. That is d bar equal to what? Means what? One times electric field intensity gives what? Our electric flux density. Epsilon. Epsilon is nothing but the permittivity of the given medium. We know that from Coulomb's law, we have what? F equal to what? One is capital Q and another one is small q. And from Coulomb's law, we have what? F equal to what? Q by epsilon r square. I consider the definition of E is defined as what? Electric field intensity force per unit discharge. Q. Means if I substitute this equation, we will get what? That is, this cube cancelled out, we will get what? R is the unit vector along R direction. E. Then let us consider this as equation 1. Substitute this E, this equation 1, we will get what? That is d bar is equal to what? Epsilon into E bar. E bar means what? That is Q by epsilon r square into E suffix r. It is the unit vector along R direction. Okay. Now this epsilon cancelled out. Get remaining thing as like this. That is d bar equal to what? Q by 4 pi r square into AR. It is the equation of the d bar. relationship between what? B epsilon E bar. Okay, from this equation, E depends upon what? This, as B doesn't depend upon epsilon. This field is depending upon the type of the medium where this point charge is located, whereas B doesn't depend upon the type of the medium where this point charge is located. Means what? E depends upon the type of the independent of the medium. Here epsilon is the medium parameter, and force, this F bar is nothing but what? Force between these two point charges. Okay, I consider one charge as positive in this cube. I consider this small q as the test charge. This electric field intensity is defined like this. Substituting this E in the relationship between D and E, we will get what? D bar equal to what? Q by 4 by R square AR. This D as what? Displacement vector. This D is also known as what? Displacement vector. As what? Electric flux density, or else it is also called as what? Displacement. Now we came to know that this D, that is electric flux density, is defined like this. That is electric flux density, or else it is also defined like this. That is on times of electric field intensity gives what? Our electric flux density. This equation relates our electric flux density and this electric field intensity. Relationship between electric field intensity and electric flux density. And D is in terms of what? Electric flux. Electric flux. Electric flux per unit surface area. This equation can be used to derive Maxwell's first equation, or else one of the Maxwell's equations. Of course, we have four Maxwell's equations. By using this equation, we can derive the Maxwell's first equation. To derive Maxwell's first equation, we will use Gauss law. Gauss's law or Gauss law simply. This statement of the Gauss law: total electric flux surface equal to charge enclosed by that volume. Charge enclosed by that volume. Once again, I am repeating this last statement. Total electric flux through a closed surface is equal to charge enclosed by that volume. I am writing here. This is the statement of our Gauss law. What it says, total electric flux through a closed surface is equal to charge enclosed by that volume. Or else, charge enclosed by that closed surface. Here, remember one thing, it is a closed surface. Closed surface means what? Closed surface defines open volume. Please underline this closed surface and volume. Here, in the okay, here what we have, closed surface and volume, means it relates closed surface integral to integral, volume integral, and we have relationship between cause and effect. Okay, what is the cause to get this electric flux or else effect? So due to charge, lines emanates from the positive charge and terminates at what? Negative charge. Is what? And what about this electric flux? It is the effect. So Gauss law is nothing but what? Between cause and what is the cause? Cause is nothing but the this charge, and what is the effect? That is this electrical flux. Okay, so or else cause and result relationship. We can write here mathematically total electric flux through a closed surface is equal to charge enclosed by the is represented by what? That is psi. Electric flux is represented by psi. It is a total electric flux. So that's why total electric flux through a closed surface is equal to what? That is charge enclosed by that volume. So let us write this flux in terms of the flux density, electric flux density. Please refer that equation where you have, so here psi is equal to what? Integral d dot ds. In that psi d, in what, that is integral d dot ds. It is surface integral, so that's why I am putting here. Of course, it is closed surface means what? Closed surface integral. Closed surface integral. We have the relationship between charge and charge density. As it is volume, let us consider volume charge density. The relationship between this charge and volume charge density is nothing but what? That is integral dV. Already we defined rho v as what? Since rho v as what? Rho v equal to what? Volume, that is dq by dv. Okay? Q equal to what? Is Q equal to what? Integral rho v dv. Okay? Means what? Here is in terms of the flux density and charge is in terms of the charge density. From this equation, we can observe that what? Closed surface integral and this one is volume integral. Means what? In order to relate these parameters, we need to convert closed surface integral into volume integral. In order to convert this closed surface integral into volume integral, we need to apply what? Divergence theorem. What is the use of divergence theorem? Divergence theorem is used to convert closed surface integral into volume integral. Let us apply the divergence LHS of to the LHS of this equation. LHS, we have what? Closed surface integral. Apply divergence theorem. Apply divergence theorem. Divergence theorem. Divergence theorem is used to convert closed surface integral into volume integral. Closed surface integral. It can be converted into what? Here we have vector, that is d bar. That vector becomes what? Divergence of, apply divergence theorem to LHS of this equation. Here I apply divergence theorem to this. Okay, this closed surface integral becomes what? Volume. And we have what? That is integral rho v dv. It implies what? So here integrals are equal. Here integrals, volume integrals. We have volume integral. Here also volume integral. These integrals are allowed. We have integrals. So as integrals are equal, integrals should be equal. What are the integrals? On the left hand side we have delta d bar. Right hand side what you have? That is rho v. The unit of this charge density. So charge is measured in terms of the coulombs. C stands for coulombs. And volume means what? That is meter cube. The unit of charge density is nothing but what? For meter. Observe these units. That is hand side are what I have? Coulombs per meter cube. Let us consider left hand side. What we have? Meter. And the unit of D is what? Flux density. Equal to charge means the unit of flux equal to the unit of charge. So that's why that is what? That's what flux per unit surface area. The unit of flux is coulombs. Surface area means the area units are. So this is equivalent to what? That is meter into coulomb per meter square gives what? Coulomb per meter cube. So this equation satisfied. This is the Maxwell's first equation. I am writing this equation here. So this is called as what? Equation. One of the Maxwell's equation. So we can call this as what? Maxwell's 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 first equation. Why it is first equation? We have four equations. Of course, we derived this equation first one, so that's why it is called as Maxwell's equation. differential form or point form or its point form. Integral form is nothing but what? This is in integral form. This is what? It is in integral form. In integral form. This is the integral form of the Maxwell's equation. Whereas this one is what? Point form or form. In today's class, what we have discussed, first we defined electric flux density. What is the definition of electric flux density? Flux per unit surface area. Okay, suppose if you have current, if you want to current density, how it is defined? Current per unit surface area. Charge density, let us say surface charge density. Charge per unit surface area. Okay, and so that is about one of the definition of the electric flux density. After that, D is also defined as what? D is also defined in terms of this, that is D equal to epsilon. This E depends upon the permittivity of the medium, where D doesn't depend upon the medium. After this, we entered into one of the important law in our electromagnetic field theory, the Gauss law. Total electric flux through a closed surface is equal to the charge enclosed by that volume. It relates what? Closed surface and volume. We know that from Gauss divergence theorem, closed surface defines what? Open volume. Closed line defines what? Open surface. That is Stokes theorem. Okay. So line to surface means Stokes theorem. Closed surface to volume means what? Gauss divergence theorem. Okay. This Gauss law relates what? That is cause and effect. What is the cause? Charge. What is the effect? Electric flux. Okay. Of course, flux line started at what? From positive to negative. So suppose if I have a positive charge like this, so field line started here, and if I have a negative charge like this, if these are placed like this, in that case, this positive charge terminated at a negative charge like this. Okay, so these are what field lines are. We can call what electric flux. Source for this one is nothing but what? So the source for these field lines or flux is nothing but what? Charge. Either it may be positive or else negative. So that's why Gauss law relates what? Cause and effect. Okay, cause is what? Charge, and effect is nothing but what? Flux. So that's why it states what? Total electric flux through a closed surface equal to charge enclosed by that one. So in order to derive this Maxwell's equation, that is del dot D equal to rho V, okay, write this flux in terms of the flux density. That is, we know that psi equal to what? Integral d dot ds, and q equal to what? Charge in terms of the equation in density. That is psi equal to what? Equal to what? The relation, that is equal to integral d dot d relation. Please see here. So as it is closed surface, consider what? Consider what? What we consider. So that is Gauss law, that is integral d dot ds. As it is closed surface, I consider this integral, and it is it's a closed surface and volume means what? We need to consider what? Volume charge. So the relationship between volume charge and volume charge density is like this. We got what after simplification delta d form. On left hand side we have integration. Here also we have integration. This is all about today's class. We will meet in next class. Thank you.